Good day. My name is Ugochukwu Ukwebu. I am a Nanodegree lead with the Udacity ALX Cloud Developer Program. I am doing a project 3 walkthrough, refactor monolith to microservices. We've previously shot a 4-part video, part 1, part 2, part 3, part 4. In part 4, we refactored monolith to microservices. We deployed, and it ended with us not getting the exact results we were looking out for. So, and that called for this part 4B video, where we troubleshoot the application to find out what actually went wrong and fix it. So let me continue with sharing my screen. All right. So where we left off, we deployed to containers, Kubernetes cluster. So we have a cluster running, and we updated our front end image, and we ended up still getting failure response. We couldn't connect to from our reverse proxy to our backend. So, one of these, when we have errors, we should look into it very well. Remember, we first put up this application, we created exposed our services, we exposed front end deployments and reverse proxy deployments to as load balancer services to give us external IPs. So we got external IPs. We came back to our code base, and we came into our code base, and we pretty much updated environments variables to have with the external IP of the reverse proxy, right? We did that. So and then we rebuilt and pushed to GitHub, from where Travis pulled and rebuilt and pushed and pushed to Docker Hub. And then from our Kubernetes service, we redeployed and pulled into our containers, the images into our containers. Now, if we look at this error, it tells us HTTP failure response for HTTP localhost. You see, it's just trying to look at our localhost to connect from the reverse proxy to the front-end application. Meanwhile, we've updated that in our code base, right? But what happened? What happened that it didn't reflect even after we know that we used Travis to build, right? And push to Docker Hub. And then even when we get to Docker Hub, we see that our front end has even the latest build, v4a tag, right? So I ended that video and went on to really look further, dig deeper, and I ran a few commands. Really, I kind of ran. Let me go back up. kubectl describe pod, right? To really look into what's happening in the pod. So let me do it live here. I do kubectl get pods, right? So I have two front-end pods running. So I do, let me see, I do a kubectl describe pod to really see what's happening, what's happening in that pod. kubectl kubectl describe pod. Then I put that front-end pod. And I look at the description of that front-end pod from the beginning, right? Now, if we look at it, yeah, front-end pod name. Now, just I want us to look at the image, right? It's the container is a front-end container ID, right? Now look at the image. It's pulling Ugo generating Udagram front-end to local, right? local. This is the previous tagged version. The first one we pushed to Docker Hub, right? But it's not the updated one. Now look at Docker Hub. This was the one that has the local endpoint. Now the one that has the v4a endpoint with a reverse proxy endpoint is v4a and not local. But we're pulling local image, the one with the local tagged image, into our containers. So that's why we were getting this error, right? So what happens? Where was the error? Where was the mistake? It was in our deployment file, right? Our front-end deployment file. Let's look at that. So I go back to my front-end deployment file and I see that I instructed the deployment files to pull the front-end image with local tag. So what happens here? I have to go back there, update it v4a, right? That's the proper name v4a, and I save this, right? And all I need to do is just apply that deployment again. First of all, before applying, let me see kubectl get deployment. ctl get deployment. One option is to kill the pods and then apply deployment again. But we can, with apply deployment, we've made a change here, right? So when we run kubectl apply deployment for the front end file, let's see, let's go back up here. Kubectl apply for front end. That's all we need, really. Kubectl apply for the front, apply configurations front end. Kubernetes is a powerful orchestrations tool. It recognizes that we've made a change and it's reconfigured the front end deployment. So let's even run apply get deployment again. Now see the magic, right? We still see that we have, now let me even run, we see that we have something available. Let's do kubectl get pods. All right, see what's happening here. You see that we have two new front end pods, 29 seconds, 29 seconds, while the others are 79 minutes, right? If we had run this a little earlier, we would have seen deployment killing the previous front end pods and then restarting this new front end pods. That's the power of Kubernetes as an orchestration tool. It compares our latest deployment YAML file with what we have, right? So it's something it keeps doing automatically. So when we ran that latest apply, it compared what we had there with what we had running and saw that there was a difference. That I asked for a new versioned image and immediately went about killing the old images of front end deployments, kill them and restarted a new one, the new versioned images, and so I have them up and running. So I believe with this, I just need a little time to propagate, and I go back, right? And I believe that let's see if it has propagated enough to give us the proper naming. All right, so I believe this is still picking up from cache, right? So I'm going to shut down this browser because I think I know with Bing, when I set up a new browser, it comes up with it clears cache by default. So let's see how that goes. Let me give that some time. But in the meantime, let's still describe this pod and see what we have new, what image it's pulling. Right? Front end. All right, so let's see what we have here. You see, this time around, it has changed, right? Udagram image to V4A. While if we scroll up, before it was pulling the, let me scroll up again to where we did that. The front end was pulling the local tagged image, right? So now we're pretty confident that it's pulling the updated image, right? Look at that. Okay, so when we do that, look at the events there, right? Pulling image to V4A, successfully pulled image, and that's what's created container front end and started it. So let's go back to Bing and restart Bing. And let's see, drop if we have that endpoint still there. Is that what we have? No, no, not yet. That's not what we have again. So let's go get that load balancer. Oh, let's see here. Come on. Or would a refresh solve it here? Let me see. It's probably still relying on cache. But let's go straight off to the latest Bing. And then run that. All right. So we see that this time around, we successfully made a connection with uh, backend pods and pulled a couple of images. Let me see. Giving time, see if this is going to clear up. Let me refresh my browser, but okay, no, not that. So this is happy. We've done our interaction. We've made it. I think give it more time. This should load properly. Uh, so now let's get on with our tasks. So let's even see what's happening in the backend pods, right? So let's say kubectl get pods. Get pods. All right. So let's see the logs of the feed pod. kubectl logs, API feed. And we see that reading what's happening in the pod, first of all, we had pod initialization, right? And then eventually we had interaction with the pod, right? Logs interacting with the pod. Now this is a screenshot. This screenshot is required to, as part of, you're required to make this screenshot as part of your project submission. You're gonna do that, put them in your screenshots directory. I think this is it, right? You prepare your screenshots, put them in the screenshot directory and submit. All right, so done that, let's go over our project instructions to see that we've done most of what we need to do to meet the requirements for our rubrics. Okay, so we've done kubectl get pods, you've done kubectl describe pods, we've done kubectl logs pod, kubectl board. Okay, now, okay, some more things we need to do, right? Kubectl autoscale pod. Now there's something we to be able to record metrics in our server. It doesn't come default by default in Kubernetes. So we need to install a metric server with this command here. All right, so maybe let me first take this link and okay. You could really look up what it is later on your own. Check that out. It's a YAML file. Okay, you could look it up. It's going to download the YAML file, but I want to introduce apply it in our cluster to, let's see what happens there. So I'm going to apply that. All right, matrix server created. Follows all the process it's happening. Cluster role binding. All right, that done. Run kubectl gets metric server, kube system. So let's see what's happening there. All right, good. Our metric server is running. So let's go back to our project instructions. Okay, let's do an auto scale. This is part of what we need to do, right? One of those things we need to have a screenshot ready for. kubectl auto scale deployment backend user. So I think I prepared the command for that here. Auto scaling, kubectl auto scaling. Let me auto scale the backend user deployment. My specification is minimum 3 pods, maximum 5 pods, CPU 10%. But before I do that, let's see what our kubectl pods. Okay, kubectl get pods. You see, before I kubectl pods. That's all right. What's happening there? All right. So get our pods. That took some time. Get pods, we can see that we have 1, 2, 3, 5 pods running. So when I run this, I'm telling to auto scale deployment API user deployment to have a minimum of 3 pods and a maximum of 5 pods based on a CPU percent, 10%, right? So okay, what do I call my okay keeps what I call my kubectl deployment. I went ahead of myself there. API user. All right. My deployment name is API user, not. Okay. So let me run that command again, make the necessary correction. So let's run that again. Auto scale deployment API user. Okay. So it's done that. Horizontal port auto scale auto scaled. So let me run my kubectl get pods again. We're going to see what's happening here. Okay, we just still have the previous, it's not yet making its impact. Can you see that what's happening now? I told it to auto scale. So it went, Kubernetes saw that I asked for 3 pods minimum. And you can see it's creating an additional 2 pods, API user pods. That's what I told it to do, scale the API user pods. So I have that. It's container creating. By now, I should see it running. Yeah, things are fine. So let's look at this. kubectl get pods, the commands we're advised to run. Look what's inside running your container. If I run this container, if I run the commands and do a printf, you can do this on your own. kubectl exec, std in, run that to see what's happening in your pod. Just replace this backend feed name here with your pod name and printf get pros. This is going to expose the environment variables that are running in the pods, right? I'm not going to do that, but you could do that in your own. Okay, let's do kubectl get pods. We've done that. kubectl describe services. Okay, you're required to submit screenshots of these commands. So kubectl get pods, grab the screenshots, save it for your submission. kubectl get services. kubectl get services. No. That was that get services. Describe services. That's okay. This is get services. kubectl describe services. So these are my running services. You're supposed to run this command and grab screenshots of the output and submit with your project submission. Okay, now let's do kubectl describe HPA. You have horizontal scaling set against CPU usage. So let's do kubectl HPA for horizontal pod auto scaling. All right, so you're supposed to submit a screenshot of this. Let's see. Okay, kubectl describe HPA warning. Autoscaling port autoscaler is deprecated. Autoscaler namespace name API user namespace default. Creation timestamp. We have that. Resources metrics current target, right? Metrics 0%. Target 10%, minimum replicas 3, max replicas 5, deployment pods 3, current, desired 3, right? And what our message is, recommendations were higher than current one, apply the highest recent. All right, so normal events, successful reschedule, 2 minutes, 25 seconds, horizontal pod to scale a new size, reason current member of replicas below spec min replicas. So with this, we're pretty much tied up. We have everything we need for our project. If you are up to it, you could still go onto your login part, run the commands. I think all the rest, we've done everything we need to do. So just make sure you review what you need to do. Prepare your screenshots with your submission. kubectl logs. We've done this. Screenshots require screenshots. kubectl logs. Pod name. We've done that. So do that. Submission requirements. Just made this up, and then clean up. This is a very important step. You know, right now we have resources spinning up on AWS. We have our RDS instance. We have our cluster resources, which has a cluster, and then our nodes, two big EC2 instances, M5 large type. So now we've done what we've done. We've finished everything we want to do. We clean up, right? Become good cloud citizens. Else, these resources will keep consuming credit, and it could rack up billings that we're not prepared to make or we don't want to make. It only makes sense. You know, that's one of the things about cloud, right? You pay for what you need or you pay for what you use. We're done with our labs. We've done everything we need to do. We've met our requirements. So it's no use. We delete them now. And if it's a production app, we have applications serving users, you leave your apps on. If you don't, if your app has is done with its use, it's done, no more use for it. It doesn't make sense keeping an app in the cloud that's not doing anything for yourself or your business. When it gets that time, you can shut down your resources. So very simple things we need to do. The steps to shut down resources is straight. I do that from console from here. I go back to my AWS console. Okay, this was the previous run that was running my node group. So I pretty much delete here. Asks me to confirm delete by typing node group name. My node group. Delete. All right. That probably going to take about 5 minutes to happen. So that's about it with our troubleshooting part, right? I didn't really plan for this. I thought it was just going to be a simple 4-part video. But at the end of that 4th video, we had a little issue. I think it's the end of the way it was. I had to go back, pause a little bit, think of what the cost might be, came back, discovered that we pulled an old image from Kubernetes, or at least, I mean, from Docker Hub. The image we had running in pods was not the desired image. So when just went back, made the configuration change, make the change in our deployment, in our front-end deployment file, applied it, pulled the desired image into our containers, into our containers in Kubernetes, and we just saw that we made a connection. So these are little things. That's one number microservices. You have so many different parts working together, right? And all of them have to come together. It's looks complicated, but it has its benefits, right? That's what this course is about, teaching us the different things. And I hope we've learned, and I hope what I ran into would help you troubleshoot your issues as you face it, right? Probably might not be too helpful if it had run successfully with no issues, because I know even in previous trials I had issues. So it makes good lessons. So part 4 has a part A and part B. Part A was the main thing, pretty much done up to 90% of the project there. But and then it completes the troubleshooting and corrected our error, and we have a full app working. So at this point, just follow your instructions. The other things you need to do: prepare your screenshots. You have our code repos. Okay, what am I doing on code? Okay, so this is out of requirements Git status. Okay, I've already pushed my retest commit to GitHub. So basically, on your own part, you're probably going to make this branch, you're going to feature branch, merge it to your main branch or to your dev branch. And that's where you're going to submit. Because when you submit, the reviewers will pull your, there are two ways to submit. Either you submit your code as a zip package or you submit the Git repo. So if you've done everything we've done here successfully, you've met all your requirements, submit your screenshots, you'll be good to go. I just want to be sure that I complete my cleaning up of my cloud resources. I want to do that here before everyone, before I end this video demonstration, because it's something I recommend everyone does. Do I still have this node group here? Still deleting. Is it really still deleting? Okay. Let me refresh that whole page. All right, my node group is still deleting. So that should delete. And yeah, any questions you might have, feel free to reach me on Slack. You can reach me via LinkedIn, and I'll answer it to the best of my abilities. Let me see. Let me try to run the command from kubectl get nodes. That's taking some time. Mm. Okay, error, unexpected error. This should try. So pretty much I expect the nodes to maybe, okay, no resources found. So I expect now that the nodes have successfully deleted. So if I refresh this page here, I expect, yeah, no node group. So next thing I delete my cluster. All right, so next thing is I'll delete my RDS instance, delete your S3 buckets, right? And yeah, you no longer accrue bills that you don't intend to. So thank you very much for joining me in this 4-part series of our project 3 walkthrough, refactor monolith to microservices. And I hope I've done justice to the project. So get along. If you do your project, finish up. Remember, the best instructions you need are in the course. The course is loaded with all the right tools you need to do a project, to understand the project and to submit successfully. Thank you. Once again, my name is Ugochukwu Ukwebu, Nanodegree lead with Udacity ALX Cloud Developer Program. It's been a nice one doing this. Thank you.